So, which topic do you know?
Sir, I have covered analog electronics and network theory. Just second order analysis is left.
Okay, second order, you haven't prepared yet, right?
Yes, sir.
Analog and circuit theory. And signal and
Yes,
system
sir.
and control part is also done, right?
Sir, signal and system, I know the basics for analog and control system. I haven't done yet, but I know basic control system that is used
Hmm.
in analysis, stability, and all.
Okay. So, okay. So this is a fresher position interview, mock interview. So I will go for the basics. Okay. Let's say
Okay, sir.
we'll try for some KCLs and KVLs. Okay. Let's say we have this.
Sir, do I need to share my screen also?
Okay. So let me provide you the question. Then you can share your screen and do the rest of things. Okay. You you
Okay, sir.
you can share my screen, right? Hmm, hmm,
Yes, sir.
hmm. So now your question is this. I want this voltage across this 1 ohm resistance. So this is your question.
Yes, sir.
Hmm.
I'm sharing.
Yes. Hmm. You can turn on your video. Okay.
Uh, okay, sir.
Okay.
The circuit was this, and there was a resistor, current source. Sir, can you tell the values? What was the
This was
voltage
V.
source?
This was V.
How much?
Uh,
V
that one was
and
1 ohm.
1 ohm
Hmm.
plus minus 1 volt,
Yes, that was
and
R.
this one was
R. Only R resistance.
R. Okay,
That
sir.
was also 1
And
volt.
this one
1 ohm. 1 ohm.
1 ohm,
And this was
and
4
current
amps.
source
4 amps.
4 amps. Okay, sir.
I want
And
the Vx
I
across
need
the
to find this.
yes. Vx. Right, Vx.
Okay, sir.
Hmm.
Okay, sir. Okay, sir.
Hmm.
Sir, so the current will be flow 4 ampere current will be flowing in this loop, and uh, this and here also the 4 ampere current will be coming back, and in this loop the current will be uh, uh, it will be flowing, no, not this way. It will be flowing in this direction, and it will be one, yes, it will be 1 ampere current. So here the current coming will be 1 amps, 1 ampere, and here it will be 4 ampere. So effective current will be in this direction, that will be 3 ampere, and Vx will be minus 3 volts.
So what you have said previously, in the lower loop, the voltage is 4 amps, right? Hello.
Yes, sir. So the current coming from here is 4 ampere. Yes, sir.
No, no. So you're like you are slightly mistaken. Like the
Uh,
1 ohm resistance carrying 3 ampere, right?
uh,
Not so
sir, 1 ohm is
we cannot tell the loop is
3 ampere. Yes, sir, 3 ampere.
hello.
Yes, sir.
So previously you have said na the lower loop is carrying 4 amps. That is wrong. Okay, because the
Yes, sir.
because
Sir, no, not the yes, sir.
hmm, because yes, the 1 ohm is carrying 3 amps, right? Uh,
Yes, sir.
in the lower loop, the loop is also consist of that 1 ohm resistance where we finding the Vx. So it was wrong, but your
Yes,
ultimate
sir.
answer is okay. So if we apply a
Sir,
KCL to the
I sir, I didn't say the complete loop. I said the 4 ampere will be leaving here and 4 ampere will be coming from here.
No, you have mentioned the loop, na? You have mentioned the loop.
Oh, okay,
So
sir,
loop
sir.
means
Sir,
the
I
1 ohm
think
is
I
also
should.
included.
Yes,
Uh,
sir.
so that yeah, it
Okay,
is okay. So nice.
okay.
Okay, it is fine, and it is minus revolve. Now,
Yes, sir.
okay, then again I am sharing. Okay, no,
Yes.
there is no issue. So write a RC circuit,
Okay.
draw a RC circuit. Hmm. Okay.
Yes, sir.
Now make a square wave in the input, square wave current going
Current.
going into the resistance. Current
Uh,
source,
okay, sir.
make a current source with a square wave. That current source is a square wave. Hmm. Yes.
Yes, sir.
Just I need to plot what will be the V output.
V out.
Hmm. V out and IC, current through the capacitor.
Okay, sir. So since this is a current source, so when let's say this is I naught, so when I naught current is flowing through it, the V out will be equal to uh, I naught uh, T by C, and when it's zero, so when it the current goes to I naught, the V out capacitor will charge and V out will increase, and when the current goes to zero, so the V out will start discharging exponentially. So output will look something like this. When the current is I naught, it V out is will increase, and when the current is zero, then the capacitor will give discharge exponentially. Again, when it becomes I naught, so it will again charge and discharge like this, and current will be I naught when it's high, and zero IC will be zero when it's no, IC will not be zero. Uh, so IC will be
Uh,
IC will be at when it's high initially, it will be I naught, and after that, when the current goes to zero, uh, the IC current will go in this direction. So this direction will
One thing. So when the current input current is zero, so what will be the equivalent
yes.
picture? What will be the equivalent circuit? Can you draw?
Uh,
When the current is zero.
oh, it will be open circuit, so it will not discharge like this. Okay, okay, okay. It will be like this. Be not. So it will constant here. It will be constant here, and then charge, and then constant, then charge, and then constant.
Okay.
Okay, sir. I short circuited it,
What about IC? What about IC current?
and current will be uh, same as I naught.
Exactly. So why this? What is the nature of this charging? Can you comment? Like which type of waveform is this?
Uh, uh, the charging is RAM,
Hmm.
and uh, IC is square wave.
So it is the overall waveform is called a staircase, right?
Oh, okay, sir.
Uh,
Staircase.
can you
Yes, sir.
tell intuitively why this linear charging is happening? Why not exponential?
It's because the current is constant.
Hmm.
Like the current source is pushing constant current into IC.
Hmm.
So the uh, capacitor, if we see its
No, it was
equation,
it,
then
it was mathematics. I can say V out is
yes, sir.
I by C into T. So this is mathematics. This is okay. But can you take
Yes, sir.
something from like component properties like capacity, resistance, what they behaves, how they behaves? So I am telling. So a constant
Okay.
current is charging the cap, right? So this
Yes,
is a
sir.
step current. So the capacitor
Yes,
is
sir.
always integrating the current. So integration of
Yes.
step is always a ramp.
Oh, okay.
Okay.
Yes, sir.
So
Okay,
this is
sir.
the
Yes,
feeling
sir.
of the component view. Okay.
Yes, sir. It's integrating.
Yeah,
Yes, sir. Right.
integrating the current. Okay. Now
Okay,
what is
sir.
the time constant of the circuit?
Uh, Time constant 6, since it's not exponential, so time constant will be, uh, if we see this circuit, so if we see what's resistance across the this capacitor, it's infinite, and C equivalent is C, so the time constant will be infinity.
So what does it signify? Infinity. Can you
uh,
explain that?
it will reach stability will be at infinity.
Steady state.
Steady state, yes, steady state will be at infinity.
Okay. So in this circuit, there the circuit is not going to settle, right?
Yes, sir.
Mhm. So now what is the maximum value of the capacitor can be in practical both cases?
What's sir? I didn't get
Like
it.
your V out is going to increase like that, right? With respect to
Yes, sir.
time. So what
Yes, sir.
can be the maximum output voltage ideally and practically?
Oh, okay, sir. Ideally, ideally it will be infinity,
Okay. Hmm.
um, but practically, I think it will not go till infinity.
So there
Mm,
is a limitation. What is that term?
yes.
Like capacitor can sustain a maximum amount of charge across a
Oh,
current. So this is
yes,
called.
yes, sir. It's a limit. It's a capacitor's limit.
So which
There are power. So it defines some power until it's used, and after that, it will break down. The capacitor will be destroyed.
so which type like the breakdown
Power.
is which type? What is that name? What is the term? This is called dielectric breakdown. Okay,
Okay, sir.
dielectric breakdown. So after that, it
Okay, sir.
cannot charge more. Okay,
Okay, sir.
okay. So this is okay. So you're okay now. Now let's
Yes,
make a
sir.
resistance across this R. Okay,
Sir, where?
across the R resistance, across the resistance, make another capacitor.
Oh, sir, like this,
Same circuit with a resistance.
like this.
Like this.
Okay, sir.
And let's say both of the capacitor are initially charged like some voltages. You can do from your let's say
Okay,
both of the capacitor okay output capacitor was at 2 volt initially
okay, sir.
and the C on voltage was let's say okay so your polarity is like that let's say this is minus 3 volt. Okay.
Okay,
Now
sir.
I'm giving a just a step input voltage.
Yes, sir.
I just want what is the V out waveform, what is the VC on waveform at the steady state. Or you can explain it fully, like from 0 to t equal to infinity.
Okay, sir. So, at t is equal to 0, the circuit, uh, there is capacitor here and one here. The capacitor are just acting as voltage source. So C1, C2, and here's V in is coming. Okay, uh, let's take it 5 volt and V out. So at t is equal to the 0, the capacitor will just act as voltage sources. Uh, so first the capacitor charge will be distributed. Charge sharing will happen at t is equal to 0 plus, and resistance at t is equal to 0, and resistance will not show any effect when charge sharing is happening. So uh, initially, let's okay, this was minus 3 volt. So initially, if I take the charge, total charge on the capacitors, uh, let's take this.
Don't go hurry. Okay, you are
Okay,
doing
sir. Okay, sir.
right things. Okay.
Okay. So at t is equal to before t less than 0, before the input was applied, the charge on the capacitor will be C1, 2, 3, and on C2 it will be so 3 C1, C2. And when Vn is applied, so the voltages charge sharing will happen, and let's say uh, after Vn is applied, voltage across this will be uh, if I take the positive side, consider this, so it will be okay, 5 minus V naught. So now if I write the final charge,
Okay. Okay. Is it five
uh,
minus V naught or V naught minus five?
oh yes sir, sir. So
It
V
remains
naught
okay.
minus 5, I'm taking, yes sir,
Previously you are
taking
taking
from
from
here,
so we need
yes sir,
to calculate.
okay sir. So C1 V naught minus 5 plus C2 V naught, and this will be V naught at 0 plus. From here we can calculate by equating them. So it will, uh, if I equate these two,
Okay, let's
3
have
C.
some numerical values. Let's say C1 and C2 uh, are
Yes sir.
same. Okay, are same.
Okay sir. So it will be, initial will be, charge will be 5 C, and if I write the final charge, this and this will get added, and it will become 2 C V naught minus 5 C. I can cancel C, and V naught will be mm, uh, 5 volts.
Five.
Yes, 5 volt it will be.
Okay, I'm okay. Now let me check the mathematical things. Okay, 5C equals so this will be 2V not C minus 5C. Huh, okay, this is okay. So now try to okay. So you can draw the waveform first, and you
Okay,
or you can do the like the steady state calculation. Then you can draw the full complete waveform. Okay.
okay sir. So now it's like this. Uh, V naught we replace is this, and this C, and oh sorry, it's capacitor, so it will be C. Here step input is applied. This is R. So if I take V naught, so V naught currently mm, it's 5 volt, and at V naught infinity, uh, at infinity it will be 5 volt only. Okay, and if I consider V across VC1, 0, VC1 0 plus is they already have reached their steady state, I guess.
Okay, so this is the values are like that. So you can assume,
Yes, sir.
go back the previous slide or previous slide.
Yes, sir.
Just make C2 is 2 times of C1.
C2.
Okay, okay, let's make C2 equal to 2C. C2 equal to 2C and
Yes.
C1 equal C.
Okay.
It will be fine.
So, okay, okay, sir. So, if I make this 2C, so this will become 4C, 3C, so it will be 7C, and this will be, uh, if it's 2C, so this will be 3C and minus 5, okay. So it will be, okay, it will be 4 volt. So uh, this is 4 volt. So at infinity, okay. So at infinity, this circuit will be this C1 will be open circuited. To complete 5 volt, which will reach here. So
So
it
both of
will
the
be
cap
five
will be
volt.
open, right? And it
Yes, sir.
will provide a very very high impedance.
Yes, sir. So uh,
So
if I
what will
write
the
its
what can be the equivalent circuit at t equals infinity?
okay, at t equals to infinity, equivalent circuit will be reduced to this. This will be like this,
So what is the V
and
out? How the
this
V
will
out
be
becomes
5
V in?
volt.
Why 5 volt?
Sir, mm, because if we see uh, normal RC circuit,
Hmm.
if we see, uh, so it will behave like this capacitor will be open circuited. So normal, it will behave like a normal RC circuit. So complete 5 volt will reach here.
Okay, so why in the normal RC circuit why the V out which is V in?
Uh,
There should be something na so that we can conclude
the capacitor will be charging.
no capacitor is open
Oh,
na.
okay. If we see it, the V naught will be rising. Uh, uh, Initially, the V naught will be uh, okay. If see, V naught will be rising. So uh, capacitors at infinity behave like open circuit because
So
DC
there is
due
so
to
what is the current?
DC current,
What is the current?
uh, current will become zero.
So how the resistance will behave if IR drop is
Uh,
0?
Resistance will be okay, at steady state will be reached, and for DC voltage, capacitors, once steady state it reach. So if we see its resistance, it shows
No,
infinite
no, that is
resistance.
okay. So that you are doing the open circuit, na. So by open
Yes.
circuiting all the cap, so why the V out becomes 5 volt or V in? Why? That is the question. Or everything is okay. It is going to steady state. Okay, okay, there is no issue.
Yes, sir.
But why this is steady state? Why it is called steady state? The current of the circuit is zero, na.
Because
Current of the circuit
yes,
is
sir.
zero. So there is no more
Yes, sir.
charging of the cap. So
Yes, sir.
if the current is zero, what is the IR drop? So I into R will be zero.
IR drop zero,
So the
zero.
resistance
Yes,
will
sir.
act as a short circuit, na. So the V output node becomes V in
Yes.
node. So that we are telling
Yes, sir.
So na, so yeah,
Okay. Yes, sir.
so that we can
Okay, sir.
come to a conclusion that so there are many perspective we can see the circuit. So this is one
Yes,
of them.
sir.
Hmm.
Okay, sir.
Okay, okay, fine. So now draw the full waveform of VC1 and V out.
Okay, sir. So, if we see V out at t is equal to 0, there will be step charging. No, no, sorry, sir.
So when I am saying full waveform, that means
Uh,
t equals minus infinity to t equal plus infinity,
yes, sir.
right?
Yes, sir.
This is
Yes,
the
sir.
complete
Yes.
waveform.
So, before t less than 0, it was 2 volt, and at t is equal to 0, it reaches to 4 volt,
Hmm.
and after that, at t is equal to infinity, it reaches to 5 volt.
Mark the all the points.
Okay, so this is 2 volt, this is 4 volt,
Now VC1
V naught. Okay, if we see VC1,
and make the correct polarity. Okay. Hmm.
yes, sir.
Hmm.
So
Okay, go up,
at
go
t is
above, go above.
okay, sir.
What was the polarity? Let me see. So I want in that polarity from minus 3 volt. Okay, right now.
Yes, sir. Okay, sir.
So
Okay, sir.
left side was plus and right side was minus for the capacitor C1.
Yes, sir. Okay, sir. So, so initially it was for t less than 0, it was
Minus 3 volts, right?
minus 3 volts, and at t is equal to 0 plus, it will be VC1. 0 plus will be 5, so it will be 1 volt, and at VC1 infinity will be it will also reach 5 volt. So voltage across this will be 0 volt.
Hmm.
So for VC1, it will be something like this. Initially, oh, sorry. Uh, Initially, it was minus 3 volt.
Hmm.
I need to extend this also. It was minus 3 volt. Uh, then it became 1 volt at t is equal to
1 volt
0
or
plus.
minus 1 volt? See the expression
Uh,
clearly.
it will be 1 volt, sir. Uh, I am taking this side plus. It
Hmm.
will be 1 volt.
1 volt.
So
Okay.
it reach, yes, sir. So it reaches 1 volt, and it discharges at t is equal to infinity.
Okay. Nice. So okay, let me see. Go above, slightly above. Okay, let me verify from my side as well. Okay, so it is 1 volt or
Okay,
minus
sir.
1 volt. So previously it was minus 3 volt and your V output reaches 4 volt and V in at t equals 0 plus is 5 volt. So VC1 1 volt. Okay, right. Correct, correct. Okay.
Okay, sir.
So so okay, so why there is a sudden jump in the capacitor voltages? Can you say? Like in general, we know the capacitor cannot change its voltage instantly, right?
Yes, sir.
But why this is happening? We can see it is a spike kind of thing, right? It is
Yes, sir.
changing instantly. Why
Yes, sir.
why this is happening? Can you tell?
Uh,
What can be the
Sir,
reason?
if we see at t is equal to 0, the resistor is not playing any role.
Hmm.
So charge sharing is happening, and if there is no resistance, so we will get infinite current.
Hmm.
So when there is infinite current, the capacitor can change its voltage instantly.
Yes, that is the thing. And there is another thing from the frequency response as well. There is a zero, right?
Yes, sir.
Do you think if there is any pole zero things, pole will be there definitely,
Yes, sir.
right? Now, what is the pole location
Yes, sir.
here?
Okay. The pole location. If I see pole location will be omega p will be 1 upon 2 2 cr.
Why 2 CR?
Okay, if I have to calculate, so Vn will be short circuited,
No, no need to write.
and
Just tell. Just tell.
uh, why, sir, this 2 cr comes from the equivalent capacitance. If we see from here, this node to ground,
Hmm.
this will be short circuited, so this will become ground.
Hmm.
Uh, uh, okay, but this is C and it is 2C, so it will not be 2C.
3C.
It will be equivalent
3C.
distance. 3C, 3C, yes, sir, 3C.
Okay. Now
This
what
will be
is
the
like?
pole
Is
location.
there any zero? Do you think is there any zero?
Zero, we want V naught to become zero.
Hmm.
So if I short circuit this V naught uh, to ground, so mm, if I see this resistance, can this equivalent resistance can give zero. So the parallel combination, okay, by SC. Uh, so this can give zero. So no, if this resistance is equivalent resistance is
So
infinite.
no, no, yes, go to infinity, or you can think the same thing. Now you are like grounding the output node. So from
Yes,
there
sir.
we need to find what is the equivalent resistance and capacitance. So directly, so if
Yes, sir.
you make the V output node ground, so there is only cap, that is C1, and that is only R, that is R1,
Yes.
right?
Okay. So 1 by C1 R1.
On by C1 or R.
Yes, sir.
Now
Okay, sir.
can you draw the Bode plot of this circuit?
Okay, sir.
So for Bode plot, what do we need? A DC gain, poles and zeros, right?
Yes, sir.
Now what is the DC gain of the circuit?
Uh, DC gain T is equal to 0. No, DC gain it will be open circuit, and this will also be open circuit. So complete this voltage will reach DC gain is 1.
Yes, DC gain is 1. And for the passive circuit, the DC gain cannot be more than 1. Okay, right?
Okay, sir.
Yes.
Okay, sir. So it will start from 1,
Okay,
and
okay, so what is the Bode plot means? dB versus 1,
uh,
right? So I want
yes, sir.
dB.
So this will be 20 log of the transfer function.
V out by V in.
Yes, sir. So uh, pole location is 1 by 3CR,
Hmm.
and 0 location is 1 by CR.
Yes.
So first the pole will be encountered.
Yes. Yes.
So when pole is encountered, it starts going down with minus 20 dB per decade, and when zero comes, it shifts to again constant plus 20 dB uh, shifted. It shifts the when zero is encountered, it shifts to plus 20 dB. So it's minus 20 dB and plus 20 dB. So it will again become constant.
Hmm. So remove that plus 20 dB thing. Okay. So make it
Okay,
0
sir.
dB per decade, right?
Okay, sir.
Now what is the DC value, DC gain of the circuit in dB? What is that? So you are
In
writing
dB,
1
it's
in this
zero,
area.
zero.
So make it
Yes, sir.
0. Okay.
Yes, sir.
In the graph, make it 0. Okay. Now can you tell what is the bandwidth of the circuit?
Bandwidth 0 to 1 by this is 3CR.
Yes.
So bandwidth is
Yes. The for the first order circuit, the
3CR.
bandwidth itself the first pole, right?
Pole.
Hmm.
Okay, sir. Yes, sir.
So nice. Okay, so let's move towards op amp. Okay. Now I am sharing. It is very
Okay,
good.
sir.
Okay. I am sharing. So I want what is the V output waveform and Vx waveform. Okay, in time domain,
Yes,
assuming
sir.
this op amp is ideal in every aspects. Okay, that is your question.
Okay, sir.
Hmm.
Okay, sir.
You can draw.
Yes, sir.
Then I will stop sharing and you can share after.
Okay, sir. Yes, sir. I've drawn.
Okay, I am not stop sharing.
Is it visible?
Yes, it's coming.
Okay, sir. Yes, so for t less than t1, there will be no current at the input. So the V out will be zero. There is no source for t less than t1.
Mm-hmm.
After between t1 and t2, there is I naught current flowing into this. So mm,
Into where? Into where?
uh, into R and C.
Yes, into Rx.
So initially, the capacitance will be short circuited. So the complete current will be flowing into the capacitor.
Mm.
Uh, so uh, this R will show no affected T1, and after this will start. So mm, okay, so this point is minus Bx. Uh, uh, Vc can be written as minus Vx minus V naught. V naught is uh, minus Vx minus Vc. So uh, mm, the capacitor voltage will start increasing as it will start charging,
Yes, yes.
and Vx. Mm, oh, so this is also there is negative feedback. So this point will be 0 volt.
Due to which phenomenon?
Uh, Negative feedback.
No,
So a
that
short,
virtual short circuit.
virtual short circuit. So Vx will be 0, and uh, capacitor will start charging. Uh, so uh, V naught will increase like this, and if we consider
V not will
uh,
increase or decrease?
it will increase in negative direction.
Yes.
Okay, and if this time period is much greater than 5 tau, so steady state will also be reached. And uh, when this is after T2, the capacitor will uh, start going towards zero exponentially. V naught will behave like this. And if we need to calculate the time constant will be RC. And this and this steady state will be reached when this capacitor is open circuited, so complete current will be flowing through R1. So then this voltage will be minus I naught R.
So when the current is flowing through the resistance,
Yes, sir.
right? So this
Yes,
resistance, like the current through the resistance has to be flown through somewhere. So where it
yes,
is
sir.
going from here, where it is going the current
Okay, so
to the output node, right?
if
But
yes, sir,
how
output.
the output node can carry some current?
Sir, if we see internally here,
Hmm.
so if it is virtual, then there will be uh, something like this inside. If we see from the output node inside the op amp,
So what is the
and
voltage source value? Dependent voltage source
this
value.
will be uh, A naught times VD is differential voltage, and E naught is the amplification of the op amp.
So the current through the resistance can flow through internally, right?
Yes, sir.
Yes, that is the thing. Okay. Okay. So now let me share the next question.
Okay, sir.
Let's you have this. I am assuming everything is fine for this MOSFET. Let's say this is GMO, like this is biased properly, and I am giving a small signal here and taking output from here. So find the gain of the circuit. Okay.
Okay, sir. So should I share?
Yes.
Okay. So there is an MOSFET, and this is RS, RD, VDD output, and is Vin. So if I use GMRD, GMR not uh, way to solve the problem. So initially, if I have to calculate the GM, so I I need to uh, short circuit the output to the ground, and this will be RS RD, and this will also be grounded. Small signal. Here's V. So let's say this is okay. This is I naught. So if I take this uh, node voltage as Vx, So current passing from here will be Gm V in minus Vx, and since this is short circuited, so this RD will play no role, so no current will be going in this direction. So if I apply KCL at this point, will be I naught plus Gm V in minus Vx, which is equal to 0. So I naught is minus Gm V in minus Vx. Okay, let me next page. So I naught is minus Gm Vn minus Vx, and the current from this will be minus I naught. So Vx voltage I can write minus I naught Rs. So if I replace it in here, this will be I naught minus Gm Vn minus and minus, it will be plus I naught Rs. So I naught minus Gm Vn plus minus I naught Rs. So it will be I naught 1 plus Rs minus Gm Vn, and capital Gm will be I naught by Gm, oh sorry, I naught by Vn minus Gm upon 1 plus Rs. And for the V out calculation, if I
Is it
see
is it
from,
is it fully correct? Check once.
okay sir, okay, this is GMV in,
Okay, let's see the final
okay sir,
expression.
GM, okay,
Yes.
GM, it will come, it will be GM.
Now it is correct.
Okay sir. So if I see voltage from oh sorry, yeah, uh, resistance from impedance from here, so if I see in this direction, uh, if it is if its lambda is 0, so here it will be infinite resistance,
Hmm.
and in this direction to the ground it will be RD. So the parallel combination will give R out is equal to RD.
Hmm. Correct.
So I can write V naught over V in as minus GM RD 1 plus GM RS.
Okay, let's make. So it is correct. Now, Ankit,
Okay, sir.
so what is this circuit? Do you know the name of the circuit?
So yeah, this is common source amplifier with degenerated resistance.
Source degeneration.
Source degeneration, yes.
So now make a normal common source stage and compare its gain, assuming GM and
Okay,
RD
sir.
is same.
Okay, sir.
No need to derive any A, just compare the
Okay,
gain.
sir.
You know what is the gain of the common source,
Yes, sir. Yes, sir.
general common source, by
RD.
taking the mod value. Okay, by taking the mod value, mod
Okay,
value
sir.
gain, because
So,
we are interested in mod gain, right?
okay, sir.
In the Bode plot, we generally do the mod value, right?
So its model will be this, and if I consider this circuit, its gain will be GMRD.
Hmm.
Uh,
Which gain is
okay,
more?
uh, this gain is more without
Hmm.
uh, source degeneration.
Hmm. But why we are using that type of things? Source regeneration, can you say?
So there are many stability issues, and if DC, like when GM is temperature dependent, so if this source uh, this current can change if GM changes. So to make the gain constant, we do this to make the gain
So
somewhat stable.
in the source regeneration case, we can see in the numerator and the denominator both the GM is present, right? So if some
Yes.
AGM changes, that is also changing in the numerator or denominator. So it
Yes.
will give a constant thing, right? And in the indicator circuit,
Yes, sir.
we want a constant thing everywhere, right? If
Yes,
it
sir.
changes with
Yes, sir.
the temperature or the VDD itself, so it is very bad
Yes,
for our
sir.
circuit. So this is
Yes, sir.
in general insensitive to the voltage supply or temperature and so on, right?
Yes, sir. And sir, bandwidth and all that also increases.
So this is the other part, but main thing is insensitive to some quantities, and we want that.
Yes, sir.
We are
Yes, sir.
sacrificing some gain, still we are using.
Yes,
So
sir.
this is the reason.
Yes, sir. Yes, sir.
Acha, now make a Bode plot of this source degeneration circuit. What will be the
Okay.
Bode plot?
Uh, if I just consider, yes, so there should be, if I consider
There is no cap, there is no
parasitic.
capacitor and no nothing.
Okay.
Just I want a Bode plot of this circuit.
Okay. Mm, just so it will be constant. If omega changes, this gain will remain constant.
What is the value of this? So like when I
This
am
will be
saying Bode plot,
20.
mark everything in the yeah, in the graph.
So
Okay, so this
this
is
one.
okay. Now make a capacitor across RS above circuit.
Okay, here.
Hmm. Now draw the Bode plot.
Okay.
Hmm. And this is your last question. Okay.
Okay, sir. So new circuit is this. There is capacitance here.
Just no need to
Mm,
any anything KCL or KVL. Just say intuitively
okay,
how
sir.
the
Okay,
how
sir.
the gain will look like with respect to frequency. That's it.
Okay, sir. So at t is equal to no for small DC gain will be same since it will be
Yes.
open circuited, and there will be a pole location. The pole location will be R 1 by RSC. So let's say uh, here we encounter a pole. So after this, the gain will decrease with minus 20 dB per decade with omega, and this will be 20 log the gain we calculated.
So what will
And
be the
here
final thing? So the slope will be minus 20 dB per decade after infinity.
no, so the slope will be minus 20 dB
Then
per
what will
decade
happen?
after the first floor.
After that, what will happen?
After that, it will start going down, and at infinity, this will be short circuited. So there will be no degeneration. Okay, so it will not go like this. Uh, at infinity, no, at infinity, the gain will be 20 log uh, gm rd at infinity.
Draw the complete plot. So it will remain or it will be decreasing or increasing or something else.
So, sir, after mm, sir, at infinity it will be 20. Sir, it will slowly decrease till infinity.
Now tell me which value is higher, 20 log GMRD or 20 log
Mm,
GMRD by 1 plus GMRD. Which value is higher and which value is lower?
okay, okay, okay. We are given higher value here, so this should be higher. Sir.
So now
This would
modify
be
your Bode plot.
okay, sir.
So like these are the more intuitive things I am telling. Okay, so you will
Yes, sir.
go home and will think how this can be think of. How many ways are there?
Mm, so
So we are 100% sure the gain at t equals infinity will be higher, and
yes, sir.
f equals sorry, omega equals infinity, the gain will be higher, and omega equals lower, at DC the gain will be lower. Okay, mod value of gain. So this is
Yes,
we
sir.
know. Uh, so now make
Sir,
it,
there's
there should be
sir. I think there should be zero also.
yeah. So if there something, so like there must be a zero, so that it this kind
Yes,
of
sir.
thing will happen.
Yes, sir.
Okay. So we are
Yes,
we
sir.
are we are like 100% sure there is a pole and there is a zero.
Yes, sir.
Okay. Now make it so, so at infinity the gain will be higher. Make it on the graph
Mm,
up to some. So this is for, let's say, some value, and make a higher
yes, sir.
higher what I can say, higher trajectory on the on omega equals infinity. We don't know
So
in between what is happening. Let's say, okay, just make a higher
okay,
line.
sir.
Yes, yes. Now we are assuming the Bode plot. So it can be a slope like 20 dB per decade, or plus 20 dB per decade, or 0 dB per
Yes, sir.
decade. So as the
Yes, sir.
if omega equals infinity, gain is higher, so the slope must be
Yes, sir.
plus 20 dB per decade. Okay,
Yes,
just
sir.
make it, mark is plus 20 dB per decade. So can you comment, pole is coming first, or zero is coming first?
Sir, pole should come first.
Yes. Hmm.
No,
Zero is come first.
zero. Yes, sir. Zero should come
Zero
first.
should come
Zero should
first.
come first.
Hmm.
Yes, sir.
And where the pole
Okay, sir.
location and zero location, can we draw from the
Okay.
graph itself?
Yes, sir. So here it will be zero location,
Yes. Hmm.
and here will be the pole location.
Okay. Now try to find the pole and zero location, and that's will conclude our interview.
Okay.
You can do anything like KCL, KVL things, intuition, and anything you can do.
Yes, sir. So for the pole location will be this, and
No.
for zero.
Pole is not this.
Sorry. Here will be 1 by GM resistance seeing from here. Okay. Pole will not be this. It will be okay. 1
So 1
by
by GM is.
GM will almost 1
1
by
by.
GM.
Hmm.
If I consider RS high,
Hmm.
so pole will be uh,
1 by GM.
GM.
GM by C.
Yes, sir.
So
So the pole will
so
location will be
intuitively we
this.
can also see that GM is a large value and GM by C will be a
Yes, sir.
large value as well, right?
Yes,
So
sir.
the
Yes,
pole
sir.
is coming at high frequency. So
Yes,
everything
sir.
we can see and verify. And
Yes,
what
sir.
about the zero value?
Okay, so for zero value, this should uh, be okay. This should be grounded. Zero output we want. So okay, this will be redundant. This will not show any effect in the zero calculation.
Hmm.
And okay, so the let's see. So okay, uh, 1 by for zero location. Yeah.
ठीक है,
If
ठीक है.
the yes, sir. Okay. Mm, From this we can calculate zero location. No, okay. This is rounded, and
So finding zero, your output should be zero, right?
yes, sir.
So when the output can zero, the current through the RD, if current through the RD is zero, small signal current, then output is zero. So
Yes,
current
sir.
through the RD, when it is possible, when this RD becomes infinity, right?
Yes,
Or
sir.
now,
Yes,
when
sir.
the RD becomes zero, then it can be zero, right?
Yes, sir.
IR drop,
Yes, sir.
or the I can be zero, so that the V out can be zero. So R can be zero if
Yes,
the
sir.
RS combination, RS and C combination can be infinity, so that the small signal current can be zero. right?
Yes.
What I am telling.
Yes, sir.
So this, if this lower impedance can be infinity, so there will be no
Yes,
small
sir.
signal ground, a small signal current. So the
Yes,
current will
sir.
be zero. So IR drop will be zero. So the
Okay.
V out will be
Okay,
zero.
sir.
So
Yes, yes, sir. So from this we can calculate omega.
hmm.
Yes, sir.
No, not the GM thing. Nah, this will be RS. RS parallel
Okay. Yes, sir.
1 by CS.
Yes, sir. Yes.
This combination, this impedance, if go to infinity, then the small signal current becomes zero. Then the IR drop,
Yes, sir.
I into RT drops is zero. So V out is zero. Okay, now make it.
Yes, sir.
So it will give a 1 by RSC, right?
Yes, sir.
So you can find R is much larger. So the pole is, the zero is near.
Yes, sir.
Okay, now make the transfer function. Like
Oh, okay, sir.
previously at DC, the transfer function was 1 by, like the mod of the thing was GMRT by 1 plus GMRS. Now I want the overall transfer function with
Yes,
in
sir.
terms of frequency.
Yes, sir. Sir, let's take the DC gain to be A naught.
Yes. Mm,
Uh, this is A naught,
mm,
and so here the pole will come, that is 1 by RSC, and there is oh no, this is 0, and the pole will come in the denominator, and it
mm.
will be by GMC.
Huh. So now everything replaced by the most parameters values, circuit parameter value. I want the A naught to be replaced,
Okay, sir.
and the sign will be plus or minus in the.
Okay, minus, sir. This will be minus.
No. I just want mod
Okay.
value. Okay, there is no issue, but I want what will be the S minus 1 by RSC or plus between in the parenthesis.
This
No. Before that, you have make a negative sign. Na S minus.
S minus.
So
Yes,
this will
sir.
be S minus or plus.
Oh, okay, sir. It should lie on the left side.
So that it will correct. Na.
Yes, sir.
Hmm.
Yes, sir. It should lie on the left side.
Now make
One
like
by.
everything.
Yes, sir. So this is the complete game.
Hmm. Okay. So I am stop
Yes, sir.
sharing and don't go out of the meeting.
Okay, sir.
Nonsense.